All right, so for this video, I'm going to be going over the word problems homework. If you just wanted to check your answers, you can go ahead and skip forward. The answers are going to be on the very last slide, so at the very end of the video. Also, feel free, to jump around. If you got an answer right, then you don't have to sit and listen to my explanation of it. So you can kind of be jumping around and just listening to the ones that you needed help on. And then last, remember that I'm just going to show you the way that I solved it, but if you solved it a different way, that's okay. All right. So starting on page 305 here. So number 12, what is the average of 3/8 and 0.125? Well, remember the average is just adding these values together and then dividing by however many there are. So this I would say is a calculator problem. Do the 3/8 plus the 0.125, divide by 2, and you should get G, 0.250. Number 19, if 9 numbers have an average of 6 and 7 of those numbers have an average of 3, what is the total of the other 2 numbers? Okay, so this is kind of 2 steps. First step is we want to use that equation that we talked about where the total is equal to A times N, the average times the number that there are. So the first part here, it says the average is 6 and there are 9 total numbers. Okay, so that gives us a total amount of 54. Then we're going to think about those 7 numbers, right? So this is kind of step 2 here, still using this equation. So the total here, it says the average is 3 of 7 of those numbers. So the total for those 7 would be 21. So then the question is, what's the total of the other 2 numbers? So now all we have to do is subtract. Okay, the total for all 9 is 54, minus the total for the 7 is 21, which gives us 33. And again, because it's asking for the total of the other 2, we're done. If it wanted the average of the other 2, we would have to divide that by 2. 22, what is Annie's average on her math tests if her scores are? And then it lists them. Again, it's only asking for the average, so I'm just going to add these 4 together and then divide by the number that there are, which is 4. Okay, and that gives me 86. So J. 28, in a classroom, the average height of 20 students is 148 centimeters. If the average height of the 15 boys in the class is 150 centimeters, then what is the average height in centimeters of the 5 girls in the class? So this is really similar to one we just did, where it's kind of a 2-step process. First, we need to find the total for the 20 students. Then we need to find the total for those 15 boys to figure out the total, or the average for the girls. So step 1, using this equation, this is going to be for all 20 people. The average is 148. There are 20 total people. That gives us a total for the class of 2,960. Just for the boys, their average is 150, and there are 15 of them. So that gives us 2,250. So then to find the girls, I need to go ahead and subtract. And also I need to then divide by the number of girls that there are. Again, this is to find the average. Okay, so when I do that, I get 142. So H. 32, based on the report card below, Carolyn's grade point average for the spring term equals which of the following? So it gives the grade for each class, and then it gives the point. And so you just need to find your average. The B is kind of representing that 3.0, or the C plus the 2.5. So you don't really have to worry about the grade. You're just using the grade point and averaging those together. So we just need to add them together and divide by 4, which gives us 3.25. A football team scores 27, 15, and 28 points in its first 3 games. If, after the 4th game, the team has scored an average of 26 points per game, How many points did it score in its fourth game? Okay, again, using that equation, total is equal to the average times the number. Well, I guess first we should add up these three amounts, right? So 27 plus 15 plus 28 gives us 70. Okay, so that's our first step. The total for those first three games is a 70. We need the average, let's see, so after the fourth game, the team has scored an average of 26 points. So we want to figure out what the total would be if the average was 26. So the average, plugging that in, is 26 times those 4 games, gives us a total of 104. So then we need to figure out, right, how do I get from a 70 to 104? So I just need to subtract there, which gives me 34. And so that's what you would need for that last game in order to get up to the total necessary to have an average of 26. 42. Jeter records the temperature outside his home each morning at 7:30 on 5 consecutive days. He uses a standard mercury thermometer and gets readings of, and then there's 5 readings. What is the average of the readings? Again, just adding these, dividing by the number that there are. There are 5 total, so divide by 5. You should get 69.8 degrees. Last one for averages. It says William has batted 150 times and has a .220 batting average. If William can manage a hit every time he bats for the rest of the season, what is the least number of times that he must bat to raise his batting average to at least a .300? And then it says, note, batting average is equal to the number of hits divided by the number of times batted. Okay, so with this one, I just did plugging in the answers. When it says what's the least number of times he must bat, that means that when you're doing this, you start with the least, right, and then go from there to see the first one that works. So I just kind of tried to figure out each option, right? If he only bats 5 more times. So first I need to figure out how many hits he's gotten out of those 150 if he has a .22 batting average. So I just went ahead and started by taking 150 times the .22. And that gives me 33. So right now he has 33 hits out of those 150 times that he's batted. So if we want to see if 5 is the answer, I'm going to take that 33 and add 5 to it because he's gotten a hit every time. So now I'm at 38 out of, again, I'm going to take 150 and add 5, so 155. And I want to see if I get his batting average up to 300, or .3. So 38 divided by 155 gives me .245. Not up to 300, so that is wrong. Okay, so then I'll go ahead and try 12. That's the next highest number. So again, I'm starting with 33, and this time I'm going to add 12 to it. Adding 12, because that's how, the number of at-bats, the number of hits that he would get. So 33 plus 12 is 45. Again, I'm taking the 150, this time adding 12, which gives me 162. And then I need to divide to see if that gets me up to 300. So that's actually just .278. So that one is not right either. Okay, using the same strategy, I'll try 18. So take the 33, add 18, so he's up to 51 hits. Take the 150, add 18, that's 168, and divide. Yep, put .304, so that does get me up to that 300. So H is the lowest number, the least number of times that he must bat to raise his batting average to at least a 300. Okay. Jumping to page 307 now. So this section is over ordering. Okay, so a restaurant offers a combo lunch special consisting of a cup of soup, a salad, and a sandwich. There are 4 soups, 3 salads, and 17 sandwiches on the menu. Starting on the first day of the year, Mike tries to eat a different combo for lunch every day of that year, but discovers that it is not possible. What's the number of the day of the year when he must repeat a combo? So we have to figure out how many different combinations are possible. This is that thing where I draw the slots and then I multiply. So there are 4 soups, 3 salads, and then 17 sandwiches. So I'm just going to go ahead and multiply together, which gives me 204 different combinations. That means there's 204 different possibilities, which means he doesn't actually have to repeat until the day after that, which would be E, day 205. 26, Samir needs to pack an outfit consisting of 1 shirt, 1 pair of pants, and 1 hat for his camping trip. So, again, setting up our slots here. Okay. He has X shirts. I don't know however many. That's what I'm going to be solving for. There's 8 pants, though, and 5 hats, and I know he's got 400 different outfits. So over here, I'm multiplying, setting it equal to 400. So 8 times 5 is 40, so really I have 40x equals 400, and then I can just divide by 40 to solve for x. Okay, so x equals 10. Two seniors are chosen to be class representatives at Louisville High School. If the class consists of 40 female students and 60 male students, and 1 female and 1 male student will be selected, how many different ways are there to select the 2 students? So I've got 1 male, 1 female, right? There are, let's see here, 60 options for the male, 40 options for the female. I'm just going to multiply those together to get 2,400 different options. J. 45, Ronaldo likes to display a selection of soft drinks next to the register at the lunch counter at which he works. Each day he chooses 4 soft drinks from the 7 different soft drinks that the lunch counter sells and decides the order in which he wants to display them. For any one day, how many different arrangements of the soft drinks can Ronaldo display? So, there are 4 slots because there's only 4 drinks that he's putting out each day. But when you think about the number of options, you're actually going to start with 7 because there's 7 different drinks that he could pick from. Again, once he's already picked one in that slot, that soda goes away. So now there's 6 options left, and then 5, and then 4. So I multiply these together, and that gives me 840. So D. And then last one. Reddy and 4 friends decide to make tin can telephones using 5 emptied and cleaned soup cans and several pieces of kite string cut into 20-foot lengths. If one piece of string connects 2 cans, how many pieces of string are needed to connect each of the 5 cans to the other 4 cans? Okay, so with this one, you might think to use that strategy we've been using with multiplication. But this one is not actually going to be using that because it's not how many different arrangements or orders can we do. It's just asking how many connections are there. So what I did is I just drew like 5 different cans, okay? If I start over here with number 1, I need to connect to all of the other ones. So right now I'm at 4 connections. So then I'm going to move over to can 2. Now, these 2 are already connected, so I don't need a new string for this one. But I do need to connect to the other 3. So I'm adding 1, 2, 3 connections. Okay, moving on to can 3. Again, it's already connected to 2 of them, so I just need to connect to these 2. So 2 more. And then can 4, the only one that it's not connected to is this last one right here. Can 5 is already connected to all of them. So all I'm doing is adding up all of those connections, which gives me a total of 10. All right, moving on to the next page, which is probability. So if the grades in Morgan's class are represented accurately by the pie chart below, what grade is a randomly selected student most likely to have? Well, with this, it's just looking at the section that is the biggest, okay? And so D would have the highest probability of being chosen because it has the biggest section. 17, 30 of the attendees of a recent meeting drove domestic cars to the meeting. If there were 40 people at the meeting, all of whom drove to the meeting, and one of them were selected at random, what would the probability be that the selected driver came in a foreign car? So we need to count up or find how many people came in a foreign car over the total number of people. Okay, so 30 of the attendees drove domestic cars out of the 40 total. So if 30 drove domestic, that must mean that 10 drive foreign cars. And so the 10 over the 40 gives us the 0.25. 22, Radio KACT is giving away 17 CDs, 10 t-shirts, and 8 pairs of concert tickets in a random drawing. If a CD is given away first, what's the probability that a pair of concert tickets will be given away next? So we just need to figure out, right, how many concert tickets are there over the total. Okay, so we also have to think that they've already given away a CD. So there's still going to be 8 pairs of concert tickets left. But originally, if we add all these up, right, 17 plus 10 is 27 plus 8 is 35. But they've already given a CD away. So I need to subtract 1 to find my new total, which is going to be 34. So 8 over 34 simplifies down to 4 over 17. So my answer is actually H. 27, if a box of cookies has 12 chocolate chip, 8 oatmeal, and 5 butter cookies, what's the probability that a randomly selected cookie is not an oatmeal? So again, we're counting up how many are not oatmeal over the total number of cookies. Okay, so there's 12 chocolate chip and 5 butter, so that would be 17 total that are not oatmeal. Over, when I add them all together, I get 25. So my answer there is C. 31. If there's a 3/7 probability of selecting a quarter from a box of coins containing 21 coins, then how many of the coins in the box are not quarters? Okay, so if there's a 3/7 probability of selecting a quarter, right, and there are 21 total coins, then I need to figure out my multiplier here to figure out the number of quarters, okay? It looks like I need to multiply by 3, right, to get from 7 to 21. So I'm also going to multiply on top to get 9 over 21, which means there are 9 total quarters. So to find the number that are not quarters, I need to take the 21 minus the 9, which gives me 12. 32, what's the probability of picking an even integer from this set of numbers? So again, I need to count how many are even out of the total. So just counting, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 total numbers, and we want to see how many are even. So 12, 14, 16, and 18. So there are 4 evens out of 9 total. So the answer is F. Okay, a fair die with 6 sides, each containing a number of dots from 1 to 6, is rolled on a table. If the random variable D represents the number of dots on the top face of the die after it's rolled, what is the expected value of D? So remember, expected value means that I need to figure out the value and multiply by its probability for each one. So when you're rolling a die, you have 6 options, right? 1, 2, 3, 4, 5, or 6. The probability of each of these has to be 1/6 every time. There's an equal chance of it landing on any of these. So then what you need to do, and I'm not going to write all this out, but you need to take the 1, so starting here, the 1 times the 1/6 plus. And then you need to do this option, 2 times 1/6 plus. And then this option, okay, and so on, until you get down to here, which is 6 times 1/6. So that, again, I would just do that all in my calculator. You should end up getting 3.5 as your final answer. 51, an integer from 10 through 99 inclusive, which means it does include those endpoints. So it includes 10 and it includes 99. Is to be chosen at random. What's the probability that the number chosen will have 3 as at least one digit? This one is just, I would say, kind of thinking through this. You want to start and kind of think, well, what numbers have 3's in them, right? So starting at 10 here, 13 has a 3, 23 has a 3, 33, and so on, all the way down to 93. And if you count, that's a total of 9 numbers, okay, right there. But then you also have to think that all the 30s, so 31, 32, all the way up to 39, also have 3's in them. That's actually a total of 10 numbers, because you're starting with 30. But you also have to remember that 33 is going to end up being in both of these lists, and so you don't want to double count that one. So far we're up to 19, but you actually want to subtract one off to get a total of 18 because you double counted 33. Okay, so there are 18 total out of, because you're trying to find the probability, so how many digits are there? 10 through 99. That is 90 total digits. So 18 over 90 is equal to 1/5. Okay, at the end of one round of a video game, a player has a chance to win bonus points. 3 balls are dropped from the top of the screen and either land in a bucket or bounce out. There's an equal chance of either outcome, and the player receives 9 points for each ball in the bucket. Let random variable b represent the number of bonus points the player receives. What is the expected value of b? So this one's, there's 3 options, and you want to think about each separately, even though they're going to be the same outcome, right? For each one, there's a 1/2 probability of it working, and you get 9 points if it lands in the bucket. So the value would be those 9 points with a probability of 1/2 that it works, okay? And then you want to do this for each bucket possible. So there's 3 chances. So you'll do that plus, and then again, your 9 points total times the 1/2 probability, and then one more time, 9 times that 1/2, which gives us 27 over 2. So J. All right, 18. The first 3 terms of a geometric sequence are, and then it lists them. What is the 5th term? So, just listing these out here. If we just start with the first 2, and because I know it's geometric, I'm thinking, what do I need to multiply by to get to the next value? So really, what I'm going to do here is, in my calculator, I'm going to do 0.5 divided by negative 0.125, and that's going to give me my multiplier. So when I do that, I get a -4, which means that to get from here, the first one to the second one, I need to multiply by -4. Okay, again, the same thing here. To get to -2, I'm multiplying by -4. So I just need to keep repeating that pattern to find the 5th term. So here, multiply by -4, you get a +8. And then our last step, do it one more time, multiply by -4, we get a -32. So our answer is J. The first term of an arithmetic sequence is 5. The common difference of the sequence is 3. What is the sum of the first 10 terms of this sequence? So arithmetic sequence, think adding or subtracting. It says the first number is 5, and then the common difference is 3. When it talks about common difference, that's actually what you're adding each time. Okay, so we're going to go ahead and add 3 to find our next number, which would be 8. Add 3 again, that gives us 11, and so on. So we're just going to keep repeating this to find our next numbers here. 20, 23, 26, 29, and then 32 is our last one. Sorry, I ran out of room. And then it's just asking what is the sum of those. So then I just need to go back up and add all of these together. I would just use your calculator. You should get G, 185. 48, a geometric sequence has its first two terms, 2 and 4, respectively. What is the fifth term of the sequence? So again, it's geometric, so I'm thinking multiply. This one's pretty easy. You just multiply by 2 to get to your next number, okay? So repeating that pattern. So 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. That's our answer. 50, in a geometric sequence whose third term is 810 and sixth term is negative 30, what is the seventh term? Okay. Okay, so we're going to use process of elimination here. So the third term, 1, 2, so the third term is 810, 4, 5, the sixth term is negative 30. What is the seventh term? That's what we're trying to figure out. So if you look at just the signs here, if you think about it, if they go back and forth, right? Because geometric means that we're multiplying by something, so they're either going to have to be all the same, all positive, all negative, but since there's two different ones, they're going to have to switch back and forth. So this one's positive, this is negative, positive, negative, so the next one has to be positive. So we can automatically eliminate all the negative answers, okay? With the two that are left, let's just try the easier one, the whole number. If it works, great, and if it doesn't work, we know it has to be J. So they're asking what's the seventh term. So if 10 is the seventh term, so right here, then I can figure out what my multiplier is, right? I divide. So do the 10 divided by the negative 30 to figure out my multiplier, okay? So that is negative 1/3. So then I can just check to see, am I multiplying by that each time to get there? So if I start here with the 810, I'm multiplying by negative 1/3. So I'm going to go ahead and do that, okay, to find all of my options here. So 810 times negative 1/3 gives me negative 270. Again, take that times negative 1/3, which gives me positive 90. And then I just want to check, does 90 times negative 1/3 give me negative 30? And it does. Okay, so I know I found the right answer. It has to be K. 53, what is the 100th term of an arithmetic sequence whose 8th and 9th terms are 27 and 31, respectively? Okay, so there are a couple different ways you could do this one. You could sit there with your calculator and just start with your last number and then find your difference, which we can see the difference here. 27 to 31 is going to be adding 4 each time, and you can just sit there with your calculator until you get up to the 100th term. The way that I did it, though, is I knew there were 100 terms, right, and my last term that they give me is the 9th term, so I went ahead and took the 100 and subtracted the 9 to give me 91 terms in between there that I'm looking at, and I multiplied that by 4 because I know I'm going up by 4 each time. So 91 times 4 gave me 364. So that's like what I'm increasing by, but I have to look at the last number they gave me, which was a 31. So I actually have to take that 31 and add on the 364, which will give me the 100th term, which is 395. And last one here. There are 5 terms in a finite arithmetic sequence, and the first term is 1/5. Which of the following is true about the median and the mean of the 5 terms? So, let's see here. Just in case you didn't remember, right, the mean is the average of those 5 terms, and then the median is the middle number of the 5 terms. So the other thing to think about is that you've got 5 numbers going on here. Okay, the first is 1/5, and I know that to find my next number, because it says it's a arithmetic sequence, I'm adding some amount each time, adding the same amount each time to find my new number. Okay, so if we want to think about the median, we know where that's going to be. That's because there's 5 numbers you're adding each time. The median has to be here. Okay. The average is going to be what I get when I add those up, right, and divide by 5. So what they said, what the book said, I guess, is we can just plug in numbers and see what works here. And I'll kind of, go over that, but then review at the end what makes sense, I guess. So they just added 1 each time, but they kept it in fraction form. So if you're adding 1, that's like you're adding 5/5, right? So they got 6/5 and then 11/5, 16/5, and then 21/5. And so we said this is going to be the median. It's the middle number, so 11/5. Now if you take a second and find the mean, you need to add all of those up, right, and divide by however many there are. So it's actually not too hard to add because they all have a common denominator. So when I add just the tops, I end up getting 55, right? So it's 55/5 all over 5, which is 11/5. Okay, and so you can see that they're going to be the same. If you have an arithmetic sequence like this, the median and the mean are always going to be the same. So now that you've seen that, hopefully you can memorize that. If you ran into something like this and you had forgotten, probably it's easier to just plug in some nice numbers and see what is true. So the answer here is C. All right, and that is it. Okay, here is just all of the answers in case you wanted to skip ahead and just check your stuff first. Sorry, I know this was over 20 minutes, but I'm really hoping you didn't have to listen to the explanation for every single answer. So yeah, I hope you could just skip through and you got help with the ones that you had trouble with. If you are still having questions over anything, we will be doing one video conference this week, so look at your Google Classroom document to see what time that will be. It will probably be on WebEx now, so go ahead and look there so that you can join that if you still have questions. If you're good to go, you don't have any questions, just make sure that you're emailing me your work. Again, send it to Mrs. Veneman this week for the math. Just take pictures of your completed note pages and your homework pages and email me those pictures. Thanks so much, guys. Bye.